Welcome back with another episode on this channel. I'm Zahinazi and we are doing Advent of Cyber 2024. So this is task 25, game hacking, day 19. I merely noticed that you are improperly stored my dear secret. So there is already a vlog or the walkthrough on this by Cyberbriars by Sakib. You can check it out. We're gonna create our own walkthrough. Dirt on the mirror, the glitch needed more, but the dirt was protected by a pesky locked door. But on need for panic, no need for dramatics. The glitch would get through with these game mechanics. Awesome. Glitch was keen on uncovering Mayor Malware's deeds today. He was sure he would find something neat. He knew the mayor had an office downtown where he kept his dirty laundry and the big old clown. He approached the site silently, not knowing the door was closed. So ultimately, at the front of the door, a smart lock awaited. The glitch smiled cause he knew it could be subverted, but oh, big surprise, the lock was eerie. A game controlled it, glitch almost went teary. Awesome. So, implementing cybersecurity best practices, hiding the door's access in a video game. Wow. Wow, wow. If you are wondering how this came to be, Mayor Malware himself will explain it quickly. Technology gets broken every day, was his claim, but nobody knows how to hack a game. Will Glitch be able to pass through this door, or will he end up with 0 as his score? Awesome, awesome. This is a really interesting room, and it is like CTF kind of thing that you basically have on CTF events, where basically you need to navigate through a game from the source code point of view. Learning objectives or understand how to interact with an executable API, intercept and modify internal APIs using Frida or Frida. Hack a game with the help of Frida. Game hacking. Even while penetration testing is becoming increasingly popular, game hacking only makes up a small portion of the larger cybersecurity field, with its 2023 revenue reaching approximately $183.9 billion. The game industry can easily attract attackers. They can do various malicious activities such as providing illegitimate ways to activate a game, or cheat codes, or using cheat engines to do all of nefarious steps. For example, you can, if you know about the trainers, you can basically activate a trainer and go through the game without needing to do anything. Basically, your health will be 100%. You will have unlimited items to use or something like that. Providing bots to automate game actions or misusing the game logic to simplify it. Therefore, hacking a game can be pretty complex since it requires different skills, including memory management, reverse engineering, and network knowledge if the game runs online. That is true. Executable and libraries. The executable file of an application is generally understood as a standalone binary file containing the compiled code we want to run. While some applications contain all the code that needs to run in their executable, many applications usually rely on external code in library files with the so extension. The library files are collection of functions that many applications can reuse, unlike an application that can't be directly executed as they serve no purpose by themselves. For a library function to be run, an executable will need to call it. The main idea behind libraries is to pack commonly used functions so developers don't need to re-implement them for every new application they develop. Okay, so for example, in gaming, we have DirectX and we have Mantle framework from AMD. So both of them can be used to access the low-level APIs of the machine. it will boost the overall performance of the gaming. For example, imagine you are developing a game that requires adding two numbers together. Since mathematics functions are so commonly used, you can implement a library called you can inherit the library or import the library called libmaths to handle all your math functions, one of which could be called add. The function would take two arguments, x and y, and return the sum of both numbers. Okay, so here's the depiction: game executable, add x and y, and libmath.so will execute it and return the sum. Note that the application trusts the library to perform the requested operation correctly. From an attacker's standpoint, if we could somehow intercept the function call from the executable to library, we could alter the argument sent or the return value. This could allow us to force the application to behave in strange ways. Awesome. Hacking with Frida. Frida is a powerful instrumentation tool that allows us to analyze, modify, and interact with running applications. How does it do that? Frida creates a thread in the target process. That thread will execute some bootstrap code that allows interaction. This interaction, known as the agent, permits the injection of the JavaScript code, controlling the application behavior in real time. One of the most crucial functionalities of the Frida is the interceptor. Like burp, right? We have interceptor, proxy interception. This functionality lets us alter internal functions, input or output, or observe their behavior. In the example above, Frida would allow us to intercept and change the values of x and y that the library would receive on the fly. It would also allow us to change the return sum value that is sent to the executable. We have game executable. We have Frida in the middle, which can basically intercept all the calls and change. And we have libmath.so. Let's take a look at the hypothetical example. In this example, a number is simply printed on the console. Well, this is .main. Let's see if we have the script. We don't have the script altogether. Maybe we have something here. Try unlock me. Okay. What we want to achieve is to replace the value with an arbitrary one, let's say 1337. Before proceeding, we will run Frida-trace for the first time so that it creates handlers of each library function used by the game. By editing the handler files, we can tell Frida what to do with the intercepted values of a function call. To have Frida create the handler files, you would run the following command: Frida-trace, and then the main, and then the -i, and then static. You will now see the main handler, but where is this executable? Is this executable? These are the handlers. Okay. But main is not there, right? Do we have main here? No, I don't think so. We don't have main anything here. Okay, let's continue. You will now see the handlers directory containing JavaScript files for each function your application calls from a library. One such function will be called say_hello and have a corresponding handler at __handler__ and then the lib_hello.so say hello.js allows us to interact with the target application in real time. We don't need to understand what the file does just yet. We'll review this later in the task. Each handle will have two functions known as hooks, since they are hooked into the function respectively before and after the function call. On enter. From this function, we are mainly interested in the args variable, an array of pointers to the parameters used by our target function. A pointer is just an address to a value. On leave, here we are interested in the return value, which will contain a pointer to the variable returned. Frida JavaScript script to intercept the say hello. Okay, we have interceptor.attach module.get export by name. Now let's say hello. On enter, something will happen. On leave, something will happen. We have pointers and not just variable, because if we change any value, it has to be permanent. Otherwise, we will modify a copy of the value which will not be persistent. Returning to our objectives, we want to set the parameter with 1337. To do so, we must replace the first argument of the args array arg0 with a pointer to a variable containing 1337. It's all good, looks good, but do we have Frida trace? Frida trace. We have it. Then there is a try unlock me, unless it is on the desktop, right? Desktop, unless let's go inside it. Let's run all these commands, maybe. Yeah, using this. So ls minus la, what we have here? We have try unlock me. Okay, let's continue. I don't want to be left out or something like that. Frida has a function called ptr that does exactly what we need. Allocate some space for a variable and returns its pointer. We also want to log the value of the original argument, and we have to use the function to int32, which read the value of that pointer. Okay, this is the, so basically it will convert the argument value to int32, so it will be available here. And since you are using JavaScript, so the var will basically take the value as int32. It will consider int32. Then we are using console.log original argument, and then we are giving the argument 0 to pointer of 1337, and then we logging the say hello. Okay. When we return the executable with the Frida, we notice that we can intercept the program's logic, setting 1337 as the parameter function. The original value is logged as expected using the following command. Dot main -1, and then there's say static. Okay. Then we have hello. Original argument is 1, 11 ms, say hello, and then the hello is 1337, original argument is 1. Now that we better understand Frida's capability, we can return to the Frida trace. We have already seen that it generates the JavaScript script to hook a specific function automatically, but how does it know which function needs to be hooked? The parameter I tells Frida which library to hook, and it can filter using the wildcard, testing all the function in all the libraries loaded. Okay, so we already started the machine. We are already in split view. Try unlock me, the frostbitten OTP. Okay, so we already inside this directory. You can start the game by running the following command. So let's run the command itself. Okay, press space to continue. Okay. Exploring game a bit around, you will find a penguin asking the pin. Okay. Let's go to this space. Okay, let's go to this penguin. What is this? Welcome to unlock. Try unlock me. Okay. Let me open it in a bigger screen. Welcome to TryHackMe 3.1.2, the only game-based log in the world. Okay, space. Not mere malware. Game aren't smart. Looks good enough. The mayor's face any log that's smart than him, smarter than him. Wanna know how it works? Not mere malware. Not and then nice. Let me explain it to you. To open this door, you will need to prove you are mere malware via our patent pending 3-factor authentication system. Sending you, something you own or something you are. It is something, a lot of things. Expand the game a bit, and you will find a penguin asking for a pin. Terminate the game instance and execute the following Frida command to intercept. Sure. Let me go like this. Okay, so let me explore the game a bit, and you will find a penguin asking for a pen. Do you mean OTP? Yeah, mention something about the first OTP. Do you have it? And here we can add the OTP and press return. Let me close it. And let's make it a little bit bigger. Here we go. Need to execute this command, which is Frida trace, and it will take this particular binary file, and it will go to the libaoc game.so, and it is important and then static. Okay, let's run this. Let's see what happens. Okay, it still run the application here. If you revisit the NPC, you can trigger the OTP function on the console, displayed as set_OTP. But how we can do that? Notice the output _Z7 set_OTP indicates that the set OTP function is called during the NPC interaction. Okay, let's see that. Space to continue. Let's go to the penguin. Yeah. _Z7 set_OTP I is triggered. It is correct. Okay. Function is called during the NPC interaction. You can try intercepting it. Open a new terminal. Go to the home Ubuntu desktop _handler and so folder, and open the Visual Studio Code by running like this. Or we can do one thing. We can do, for example, okay, so it is already there, handler, and open terminal. Just open code dot. It will open everything for us. Okay. Now there we go. Let's make it a little bigger. Can I make it a little bigger? Come on, man. Good. Let's go with the 18. Let's see. Okay. This is what I have set. Okay, if this is applied here, yeah, it is applied here. So this is, I think, the file that we are looking for. It is logging in and we are leaving, so we have both of the values here. Good. At this point, you will be able to select the OTP JavaScript file with the hook defined, and the I at the end of the set OTP function indicates that an integer will be passed as a parameter. Yeah, OTP I, yes, okay. Good. It will likely set the OTP by passing it as a first argument. To get the parameter value, you can use the log function, specify the first element of the array on the enter function. Your JavaScript file should look like below. So on enter, we need to do that. Define handler and log parameter, and then the argument 0.2. Okay, let's do that. It is already logging, and here we go. We paste and save the file. You should be able to log something similar. Okay, then you need to use that parameter as an OTP. This value changes over time, so it will be different. Okay, should be able to log something similar. Okay, do we need to run it again or something like that? Wait a moment. Minimize it and space. Okay, so do we have an OTP? We don't have an OTP. Let me close it. Let's close it again, and let's run it again, and let's see if we are able to get this function, or if this one is changed. Yeah, it is not changed. That means it is taking the current value. So here we go. Space. Let's go to the penguin. Space. And parameter is 280493. Awesome, man. I like this. So this is the first one, right? So it is 280493, and return is enter. We did so. Ding ding. Welcome back, Mere Malware. You may now proceed. The flag is this one, THM. How we can copy it, man? THM, then 1_tough_password. How we can log the actual value, right? So let's go with what is the OTP flag? So it is THM, then 1_tough_password. 1_tough_password. So this is the first flag. Hopefully it will accept. Awesome. What is the billionaire item flag? We'll see it later. This is done and dusted. Now try unlock me a wish list for billionaire. The exposing new stage, we will find another penguin with a costly item named right for pass. Okay. The game lets you enter the coin by using the old PC on the field, but getting the coins that way sounds tedious. You can again use the Frida to intercept the functions in charge of purchasing the item. This time it is a bit more tricky than the previous one because the function buy_item displays as Z13 valid underscore purchase I. That means 3 inputs, integers will be returned, has 3 I letters after it, name to indicate that it has 3 integer parameters. You can log those values using the log function for each parameter trying to buy something. Okay. So, all right. So let's get to this stage first. We press space. Okay. Do I need to again interact? Yeah, I get it. Now, who else I have here? Let's go. There is a computer and there is a penguin here again. Let's interact with it. You are now verified to at least 1/3 of the mayor's malware. Congratulations. Awesome. Second authentication factor is a wish list for billionaire. Sound shady. How does that even work? I'd be silly to tell you whatnot. Let's move forward. Does he pays $1 every time he needs to open the store? He does, but then refunds the product. I should be rich by now, if not for the cheap mayor. But hey, if you are having cash issues, you can always mine some coin from the old PC. Is that anything you want to buy now? Okay, so we don't have anything here. Please enter the item ID to purchase. Okay, let's go with 3 and press return. Checking your credit card. So this is the item that this is the function that is caused. We don't have anything, so we need to maybe go to the old PC to mine some coin. So this is the validator underscore purchase. So let's open up our Visual Studio. Here is the function we are looking for, and we already have everything here. Let's log all the values first. Okay, the game lets you, we already done so. You can log those values using the log function for each parameter trying to buy the something. So let's do that. Let's add all of these in here. So all of the statement are ending with semicolon, so make sure we are adding the semicolon. I hope. Yeah, they are doing the same, so we need to do the same here. Instead of doing anything, he just logging with the string, and he's not using to int in here. You should be able to log something similar. 0x1 0x5. Okay, let's see. So I'm gonna save this file and let's run this again. Let's see if the new code is working. Yeah, we have 300 and million and 1. So we know that the flag 2 is this one, this item basically. This is the purchasing cost. So we can make it like 0, and we can purchase the basically the amount, the flag 2. All right. By simple inspection, we can determine that the first parameter is the item ID. The second is the price, and the third is the player's coin. If you manipulate the price and set it to 0, you can buy any item that you want. So argument 1 is PTR 0. So let's put the argument 1 is equal to PTR 0 like this. So where is our source code? Go to the Visual Studio. let's go through it again. Space. Let's go through it again. I'm gonna go with the 3 and enter. Here we go. So we have our second flag. So this is THM credit card underscore undeclined. So this second is THM credit card undeclined. Here we go. What is the biometric flag? Okay. Space. We are good to go. Let's continue. So here is the penguin again for the last one. Just one more factor to overcome to fully become mere malware. Last authentication factor is a biometric. At last, a normal authentication factor. So whose eyes do I need? Eyes. This is a punch-based authentication system. Mere malware has a very specific way of punching the keyboard that nobody can replicate. And here we go again with the madness. Let's continue and space. Please put your fist in the keyboard. What? Okay, so this is the basically method it is being called. So it is biometric PK and then C. C is character, I think. Let's open up our video studio. Here we go. And C is one character or what not? Wait a moment, let's see the explanation here. Try unlock me, naughty fingers, nice hack. Okay, so this last stage is a bit more tricky because the output display by Frida is like this, so it does not handle integer anymore, but strings makes it a bit more complex to debug. By selecting the JavaScript file, you can add the following code to the enter function as you did previously to debug the content of the parameter. So we need to use the memory.read C string and then argument like this. Okay, so there is a specific way to do it. All right, so let's do it like this and this one at the end. Okay, so this is the parameter. Wow, it's a big one, man. Okay, I should be able to log something similar. This operator does not seem very helpful. You may have to consider another way. You can log the return value of the function by adding the following log on the leave. Sure, let's do that. Retval. So let's open in this way. Retval is here. So paste the command and save it, and let's run it again. So return value is 0x0. You should be able to log something similar. Yep. So the value return is 0, which may indicate that it is a boolean flag set to false. Which value set it to true? Can you trick the game into thinking the biometric check worked? The following section will set the return value to true. So ret value dot replace ptr1. Okay, let's do that. Put it, paste, and save it. Let's do it again. We can add any value. Yay! THM, don't smash your keyboard. THM, don't smash your keyboard. So here is our last one. THM, don't smash your keyboard. Awesome. This was really interesting, huh? If you like the today's task, you can check the memories of Christmas past from the advent of cyber, the last year cyber. The second penguin gave pretty solid advice. Maybe you should listen to him more. Okay, so thank you guys for joining me on this journey. We completed our task 25, day 19. Once we come back, we're gonna start with the day 20, and hopefully today we're gonna complete all of the remaining tasks, which are just 5 left. Thank you guys. If you like this video, please give it a thumbs up. If you haven't subscribed, please subscribe to the channel. Help us build the community. Put your comments in the comment section down below if you have any, and I will see you in the next video. Bye.